Greetings and welcome to the iSet Robotics MOOC M2 Unit 1. I'm Dr. Patricia Goos and I shall be presenter for this unit. The focus of this unit is the use of the sensor that is attached to a robot and the use of the input data from the sensor in the flow control programming structures. It is really important that you read and access this MOOC content at least once a week. You should have access to a LEGO Mindstorms EV3 robot or the NXT, the previous version, or you can use the Virtual Robotics Toolkit or a LEGO Digital Designer. These can be freely downloaded from the internet. We also highly recommend that you engage in the iSet Robotics Coach Mentor community and you participate in the iSet Robotics live online learning sessions. So what is a sensor? Well, a sensor is a device that is used to detect or measure some physical property of the environment where the robot is moving, and it's usually attached with connectors to the structure and then wires to the processor. The orientation of your sensor then obviously depends on the use of the specific sensor. Seen below are some examples of sensors that can be attached to a robot. As can be seen here, there are a number of different sensors. So you've got the gyro sensor, the color sensor, the ultrasonic sensor, and then the touch sensor. Each of these sensors can then be attached to the processing or the brick by means of wires, and they're usually attached by means of wires that connect the sensor to the input port. The programming thus far has been sequential. So if you look at the example, you'll get reset and then move straight and then wait and then turn and then wait and then reverse and then there's a sound. But it's not always the case. So below are the flow control structures. Sometimes elements of programming code need to be repeated, and sometimes there's a decision that needs to be made based on the input data. In Unit 1A, we have sensors and sensing using the loop structure. The build will focus on the attachment of the sensor to the robot. The program focus of this unit is the iterative flow control or the loop structure and then using input sensor data in the programming. As you can see here, for the build activities, the sensor is attached to the front of the robot. In this case, the ultrasonic is facing forward so that it can detect obstacles in front of the robot, whereas the color sensor is attached facing down so that it can detect the change in color of the ground over which the robot is moving. So how to attach a touch sensor? The touch sensor can always face forward close to the surface so it will bump when it bumps into an object. If you put the touch sensor to the back of the robot, then when you reverse, you will know when you've touched an object. If you put the touch sensor mounted upwards, you can use it to start the robot as seen on the picture. So how is it attached to the robot? If you have a structure, it'll be connected using connectors, whereas if you want to actually function for the function, so the data input can actually go and be processed, you will need a wire, and that goes into input port 1, 2, or 3 of the robot brain. So how to attach an ultrasonic sensor? Well, the ultrasonic sensor is used to detect objects, and it's measuring with a receiver or a transmitter and a receiver, and then measures the distance from the robot to an object. So if you'd like to detect an object in front, you'd obviously have to mount your ultrasonic sensor in front of your robot, preferably at the bottom so it can detect an object. If it's too high, it'll probably miss the object. If you can put it on its side, it's like holding out your hand along a wall, and then you can feel as you travel along a wall. Remember, it's a sound wave, so when you are using an ultrasonic, the surface should preferably be flat. If it's slightly curved, convex or concave, you always have a reflection or a deflection of your sound wave, and then it's not actually really going to work. It's a good experiment to do nonetheless. So how is it attached to an ultrasonic, the sensor, to a robot? It's got to have a well connected by means of a connector, and then there's a wire, but for the ultrasonic it's always in port number 4, because remember there's 2 data submissions that goes. One is the transmitter and the other one is the receiver. Okay, so how to attach then the color sensor? The color sensor, if you place it forward, you can detect a color in front of the robot. If you face it down, you're either going to find or follow a line. Usually if you're following the line on the left-hand side, then the robot color sensor is mounted towards the left of the left wheel, and then similarly on the right-hand side, if you're following it on the right-hand side, it's in front of the right wheel. And what is used to attach a color sensor? Well, it's a connector, and then there's the wire that's either in port number 1, 2, or 3. There's no convention here though. Right, so we're not going to really say much now about the gyro sensor, just knowing that the gyro sensor can detect how much the robot is actually turning, and you'd also connect it with a connector and then with a wire to input port 2, 1, 2, or 3 to the brain. We'll get some more details of this later. Okay, so Unit 1, the building activities, was focusing on actually attaching the sensor to the robot. This part, we now focus on the programming activities and the programming specifically now of the loop structure. You'll find the loop structure or the flow control structures at the bottom of your canvas, your programming canvas, as you can see on the right-hand side, right at the bottom. There's a green tab, which is all the robot movements, and then if you click on the orange tab, you'll get to all the flow control structures. So the loop control structure allows for repetition of execution of code, okay, until a condition is met. So if you look at your example where there's that blue icon inside the loop structure, you've got to put your code there where that blue is. That's kind of the placeholder for your code. And as it goes here, the control structure of your loop is infinity. So until infinity, you're not going to be able to get out of this loop. So this is what we call an infinite loop. So what you do have is there where you see the blue infinite sign, the infinite sign is blue. You actually can click on that, and then you select which sensor you're going to use, and then you need to identify which value of the sensor input data you're going to use. And as soon as that we call that the loop control is then true, then you can go out of the loop, and then it's no longer an infinite loop. So this is what I was explaining previously. If you click on that infinite loop, then you have a whole lot of options to choose from. So you can choose brick buttons or color sensor or gyro sensor or infrared or robot motor rotations, or you can even use a temperature or a timer or a touch sensor. So those are your sensors that you can use. And then what I've highlighted there is like color. You can say, okay, so we have a color sensor which we're going to use to control this loop, but what aspect or what data value from the color sensor are we going to use? Are we going to use a color value? Are we going to use a reflected light intensity value, or are we going to use an ambient light intensity? I'll give you more details of that in the next unit. Okay, so this is an example of a loop, and it's going to loop until, and then the touch sensor, can you see the touch sensor is port number 1, and it shows a picture of a touch sensor, and then you've got to choose which one. So option number 2 is then bumped. So if you read the whole code, you'll see that the loop will continue until the touch sensor, which is attached to port number 1, is bumped. If you've put the motors on inside the loop, you do need to put the motors off outside the loop. Okay, so this is a very similar structure. Again, it's the loop, and the motor or the robot will continue to move with a power percentage of 50 forward. So we put the motors on inside the loop and obviously off outside the loop, but it'll continue then, the robot will continue to move then until what? Until the ultrasonic sees an object which is less than 20 centimeters ahead of it. Okay, so as long as there's nothing in front of your robot will continue to move until your ultrasonic, which is attached to port number 4, sees an object which is less than 20 centimeters away, and then it will stop. Okay, here we have a loop structure again, same structure, but now we've chosen to take the color sensor on color. So we say here, put the motors on, and inside the loop it'll continue going until the color sensor that's attached to port number 3 sees the color red. We've selected the red color. As long as it sees that red color, it will then stop. What I do need just to add here now is that if your robot is going too fast, if it's going at 50% power, it's going quite fast. But if it's a thin red line, a very, very thin red line, your robot is probably going to miss that, because remember, it's taking multiple readings. It would be more likely to find a larger area of red and then stop. It's good experiments to do to see how long it takes going into a red area, how long it takes for the robot actually to detect that it's detecting red. Okay, and then again, it's the same loop structure again. This time we say it's got to travel for 10 seconds and then it must stop. Same structure, also with the sensor. In this case, it's time. It's not a sensor that's attached to the robot. It's just time that passes. So put the motors on, wait for 10 seconds, and when 10 seconds have passed, then you put both motors off. Great, now we've got to unit 1, but the B section, and we're still on sensors and sensing, but now we're going to use decision making flow control. Okay, it's also on your flow control tab, and we're also going to use all the sensors we've just investigated. So what is shown here now is the flow control structure for a decision. So you can see that you come to a point where you've got to choose either true or false, or left or right, or so. If you can see how the structure branches, if you read it, it says that if the touch sensor is just touched, all right, in port number 1, if it is, then it's going to go to the top and say this code is going to be executed. So whatever code you've put in there, that'll be executed. If it is not, then the bottom is then the false situation, and that is the code that will be executed if the condition is not true. Okay, so there's always 2 values here. And this just shows you that there are the 2 values. So the top one will happen if you'll see the correct mark. If it's true, that's what the code is going to execute. If it is not true, then the lower part, that's what the code is going to execute. Okay, so we continue with the switch, and the switch has got a touch sensor on it. So you can see we've put the switch into the loop. So the robot will, if you can read from left to right, the robot will continue moving with a 50% power until the sensor in port number 1 is not bumped, just touched, okay, lightly pressed. All right, so now if it is pressed, then we'll take the top path, and the top path says stop both motors, because now we've bumped into something, wait for 1 second, and then reverse a little bit, and then you continue. Okay, if it is not bumped, then it'll just say hello, and it continues. What is amazing is if you let it run and not let it bump into anything, see how many times it repeats the word hello, hello, hello. It'll keep saying hello until it bumps into something, and only then will it stop and reverse. And then if you look at the end, the total on the outside, you've got a loop, and the loop is not going to go forever. It's only going for 10 seconds, and then it'll stop. Okay. All right, so very similar structure. Again, you've got a decision inside of a loop. So the decision goes, go forward. If you see red, then you must stop, pause for 1 second, reverse a little bit, and then continue. If you don't see red, just say hello, 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 hello. It's going to keep going hello. Luckily, it's not forever, because you can see that the loop outside, the whole structure outside, is only going to last for 10 seconds. So the robot will only say hello, hello, hello for 10 seconds. So here I've got some links for you, so like what are sensors, and then the Riley rover has building instructions to attach all sensors. So it's a good start, okay? And it's a good start to create a frame of reference for all learners of how to connect sensors. Let them first master just connecting them, and then we can start playing around. All right. Again, there's just some more designs, different types of robot designs, and maybe each design has a different way of attaching a sensor for a specific purpose. If you don't have a robot, please download the Lego Digital Designer and start building your own robots, even if it's just on the computer. So we've come to the end of Unit 1, and there is some assessment that needs to be done just to make sure that you've grasped the concepts. There's a quiz for Unit 1A and Unit 1B. There's a building and a programming part. And then you've got to complete, I would highly recommend, complete some of the building and the programming activities presented here, and then also some of the building and programming activities for the switch structure. There's a self-study here as well. If you can figure out on your own how to create my blocks. We'll get to it later, but it'll be good enrichment for you if you can do some self-study. Thank you very much for your attention. I'll see you in the next unit. Bye-bye.